This is GCSE Mathematics Practice Test Set 2, Paper 2H. Question 1. It says a box is on a table. The area of the box in contact with the table is 1,500 centimetres squared. The pressure on the table is 28 newtons per metre squared. So the first thing we need to notice is that they are different. Work out the force exerted by the box on the table. Give your answer to the nearest whole number. Well, we're given here that pressure equals the force divided by the area, but we need to have consistent measurements there. So 1,500 centimetres squared, to convert that into metres squared, we need to divide that by 100 and then divide it by 100 again. So because there is 1 metre squared will be 100 by 100 centimetres, which will give us 0.15 metres squared. Using the formula that we've been given, the pressure, 28 newtons per metre squared, is equal to the force divided by 0.15. So to work out the force, we do 28 times by 0.15, which will give me 4.2 newtons. Question 2. Bilal is making sets of 3 candles. He puts a white, a silver and a gold candle into each set. The candles are sold in the packets of different sizes. There are 25 white candles in a packet, 12 silver candles in a packet and 8 gold candles in a packet. And he wants to use all the candles, so we need the same amount of candles for each one. What's the smallest number of packets he can buy? Well, basically we need the lowest common multiple of 25, 12 and 8. Now we could write out the 25 times tables, 12 times tables, 8 times tables until we find a common multiple, but it's quite a large one in this case. So what I'm going to do is I'm going to use prime factor decomposition. So 25 is 5 times 5, 12 is 3 times 4, and 4 is 2 times 2, and 8 is 2 times 4, and that is 2 times 2. So if we put that into a Venn diagram, if this is the number 25, this is the number 12, and this is number 8, then 25 is 5 times 5, and they've only got 5s in 25, so that's there. Now, 12 and 8 both have 2 2s in, so we could put 2 2s in there. We'd need the extra 3 in there, and we need an extra 2 in there. Now, to get the lowest common multiple, we multiply all those numbers together. So it'd be 2 times 2 times 2 times 3 times 5, and another 5. So if you multiply all those together, you get 600. So we need 600 of each candle. So if we do 600 divided by 25, that will give us 24 packets in there. If we do 600 divided by 12, that means we need 50 packets of silver. And if we do 600 divided by 8, that will mean we need 75 packets of the gold. It says, how many sets of candles can Bilal make from the packets that he buys? Well, he's getting 600 of each candle and he's putting 1 in each packet. So it's really simple, it's just 600. Question 3. A square has side length 8.4 centimetre. Work out the length of the diagonal of the square. Well, the diagonal of the square is that distance there. And if it's a square, we know that that's a right angle, which means we can use Pythagoras because we've got a right angled triangle. And if that's a square, then it's 8.4 and 8.4. So if we call that x, Pythagoras says that hypotenuse squared, or x squared, is equal to 8.4 squared plus 8.4 squared in this case. So x would be the square root of 8.4 squared plus 8.4 squared. Now, when you put it in your calculator, make sure the square root goes over all of that, or do you put it in brackets, depending on which calculator you've got. And if you put that into your calculator, you should get 11.87939 going on. But we only want 3 significant figures. So we want the first 3 digits. So we're going to cut it off there. Now it stays 11.8 if this number was was less than 5, but it's not. So we need to round up, and that would be 11.9. Question 4. There are a total of 120 counters in a box. There are only red and blue counters, and there are 3 times as many red as there are blue. So let's just start off with that. Red to blue is there are 3 times as many reds as there are blues. Now there are 120 counters in the bag. So if we do 120, and 3 plus 1 is 4, so 120 divided by 4 is 30. So if we times each of these by 30, that means there must be 90 of those and 30 of those in the bag to start with. It then says that Carl takes a third of the red counters out. So a third of 90 is 30 again. So if we take 30 out, we're left with 60 of those. And then Kerry takes 80% of the blue counters out. Now to work out 80%, we do 0.8 times 30, which is 24. So if we take out 24 counters, we're left with just 6. So the ratio is 60 to 6, but it wants it in its simplest form. So you can see that both of those divide by 6. So 60 divided by 6 is 10, 6 divided by 6 is 1, 10 to 1. Question 5, the diagram shows a circular pond with a path around it. The pond has a radius of 5 and the width of the path is 1 metre. Work out the area of the path. Well, basically, we've just got 2 circles here. A big circle, which has a radius of 6, 5 and 1, and a small circle, which has a radius of 5. So if we do the big circle, take the small circle, we should get the area of the path. So we need to know that the area of a circle is pi r squared. Make sure you don't get mixed up with that. And then we do pi times 6 squared, take away pi times 5 squared. You can just put that all into your calculator in 1, it will give you 34.55751 and so on. Alright? It says we want 3 significant figures. So again, we want the first 3 digits. And again, if this was less than 5, we would just leave it as it was. Because it's a 5 or more, we round up, so that'd be 34.6. Question 6. It says the total cost of 3 apples and 4 pears is £1.84, and the cost of 5 apples and 2 pears is £1.76. Work out the cost of 1 apple and 1 pear. Well, first of all, we've got that 3 apples and 4 pears is worth £1.84, and that 5 apples and 2 pears is £1.76. So this is actually a simultaneous equation question. We'll notice that we've got 2 pears in this one and 4 in this one. So if I double this, I'm going to write it above. We get 10 apples plus 4 pears is equal, and £1.76 doubled is £3.52. Now, if we take those 2 away from each other, we'll get rid of the pears. So just ignore this a little bit here. 10 A's take away 3 A's is 7 apples. 4p take 4p is no pears. £3.52 take away £1.84 is £1.68. Use a calculator at these stages, because this is where a lot of people make silly mistakes. Make sure you check out with a calculator. If you divide that by 7, you get that 1 apple is 0.24 or 24p. And it asks for it in pence, so it'll be 24 pence. If we put that into the one of the original ones, so I'm going to put it into the first one. So 3 lots of 24 pence plus 4 pears is equal to £1.84. So you take the 3 lots of 24 pence off, you'll get that 4 pears is worth £1.12. And if you divide that by 4, you get that 1 pear is 0.28 or 28 pence. Again, use a calculator at each stage, even though it's tempting not to. Question 7. Is a right angled triangle. Work out the size of the angle marked x. Well, we've got a right angled triangle, so it's either Pythagoras or trigonometry. And because we've got an angle, it must be trigonometry. So we're going to be using SOHCAHTOA. Now, this one is the opposite, and this one is the adjacent, because this is the hypotenuse that's across from the right angle. So we're going to be using tan. So it says that tan x is equal to the opposite over the adjacent. So to work out tan, to work out x, we do inverse tan, so shift and tan, and it should open up your brackets for you, and then 14 divided by 7.5, and that will give you 61.8214 going on, and it asks for it to the nearest degree. So at the minute it's 61.8, so we round that up to 62 degrees. So question 8, it says Jake is making badges of different shapes. Badge A is the shape of a trapezium, and badge B is the shape of a rectangle. It says all measurements are in centimetres, the perimeter of badge A and badge B are equal, and we need to work out the area of badge A. So we're working out area, but first of all we're going to be using perimeter. So if we work out the perimeter of shape A, the perimeter of shape A, 3x, 3x, 3x and x gives us 10 x's, and then plus 1 is plus 2, 2 is nothing. So we've just got, the perimeter of shape A is 10 x's. The perimeter of shape B, that must be 4x minus 5, 2, and that must be 2x minus 3, is the same as that one. So all together there, we've got 12 x's minus 16. If we put these equal to each other, we have 12x minus 16 equals 10x. Take 10x's off both sides, we get 2x minus 16 equals nothing. Add the 16 to both sides, we get 2x equals 16, and therefore x must be 8 divided by 2. If we substitute that into each of these, 3 times 8 is 24, take 2 is 22. That would just be 8 and we don't need either of these, we just use those for perimeter. So the area of shape A would be the top and the bottom, divided by 2, multiplied by the distance between them. So to work out the area of shape A, we're going to do 22 add 8 divided by 2, and multiply that by the distance between them, which is 24. So that would give us 15 times 24, which would give us 360. Now at this point, a lot of people lose the final mark, its area. So we need to put centimetres squared. There's actually a mark for that, make sure you put it on. Question 9. ABC is a parallel to EFGH. GB is equal to GF, so we've got those little lines on there to show that. Work out the size of angle marked X, given that this one here is 65 as well. Well, we've got to give reasons for each stage of your answer, so this is the bit where people lose marks. So work out each bit and put a reason as you go. So first of all, I know that that's going to be 65 because they are alternate angles. So angle BFG, so angle BFG equals 65 degrees because it is alternate to angle and this one here, so ABF. ABF. Next thing I know then is that this is also 65 because this is an isosceles triangle if those two sides are the same. So this angle here is FBG. So angle FBG equals 65 degrees because base angles in an isosceles triangle, and don't worry about the spelling, just try your best, isosceles triangle are equal. I then know that that must be 65 at 65 is 130, which makes that to be 50. So I then know that angle BGF, so angle BGF is equal to 50 degrees because angles in a triangle add up to 180 degrees. Now it's really important you put add up to. Lots of people put equal to. Equal to means that all three angles would be 180, and that's not true. They add up to 180, so make sure you write that out in full. And then finally, angle X would be 130 degrees because angles on a straight line add up to, again, 180 degrees. Okay, now it's a lot of writing, but you've got to write in full sentences. You've got to make sure you're using these keywords. So, keyword there is alternate. Here we're after base angles in an isosceles triangle are equal. Alright, really important. Here we've got angles in a triangle add up to 180. And again, angles on a straight line add up to 180. Really, really important. Question 10. A circular clock face centre O has a minute hand OA and an hour hand OB. OA is 10 centimetres, it's shown on the grid, and OB is 7 centimetres. Work out the length of AB. So we're after this distance here. Okay. Now we've got a non-right angled triangle here. We're after a third side, and we do know this angle because a full circle is 360 and a clock is split into 12 equal parts. So 360 divided by 12 is 30. So each of these must be 30. So 30, 60, 90, 120, 150. So this angle here must be 150 degrees. So when you've got two sides and an angle between them, you're going to be using the cosine rule. So if you're not sure about that, you need to revise it up. But the cosine rule basically says that if this is the side opposite the angle, we say that a squared is equal to b squared, which is 10, c plus c squared, which is 7, minus 2 times b times c times cos of the angle between them, so cos 150. So a squared would be equal to 10 squared add 7 squared is 149, minus, and 2 times 10 is 20 times 70 is 140, cos 150. Now again, you can just put that straight into a calculator by square rooting all of that, and make sure you square root angles over all of it. So 140 cos 150. And that should give you A to be 16.43908, carrying on. But it asks for 3 significant figures. So we're going to chop it off after 3 significant figures. And this number is less than 5 this time, so it's just going to remain the same. So it'll be 0.4 centimetres. Question 11. There are 200 workers in a factory. The cumulative frequency table gives information about their ages. On the grid opposite, draw a cumulative frequency graph. So with a cumulative frequency graph, you plot the end points, which is really important. A lot of people plot the midpoints. That's for working out averages and things like that. So plot the midpoint with the cumulative frequency. So if we go over to our graph, we should be plotting. The first one was at 2025, so as accurate as you possibly can. Then the next one was at 3070. Again, be as accurate as you can. The next one is at 138. Now each square is worth 2, because it's only 5 squares for each 10, so it'll just be 1 square down there. The next one is at 175, so right in the middle. The next one is at 186, so 3 little squares up. And then the next one is at 194, so 2 little squares up, and then at 200. And then we'll join that with a nice smooth curve from 0. We can start at 0 because our tables all started at 0. So be as accurate as you possibly can here, and get it a nice smooth curve through every point. Do not sketch. You've got to be accurate. Part B, it says Graham says that 10% of the workers are older than 65. Is he correct? Well, there are 200 workers, so 10% of 200 equals 20. So if he's correct, then there should be 20 people that are older than 65. If we go back to our graph, if we go to 65, which is just here, so right in the middle, and we follow that up, again use a ruler, be as accurate as you possibly can, that gets us to 190. So that means there are 190 people that are 65 or less. So we need to do, apologies, so on here, there were 200 workers, there are 190 of them that were 65 or less, so we take that away, that means there are 10 workers that are 65 plus. So no, he is wrong. Next question. It says, when a number is reduced by 30%, the answer is 17,920. What was the number? Well, if we knew what the number was, we would multiply that by 0.7 to knock off 30%. And that will give us the answer, 17,920. So to work out what x is itself, we do 17,920 divided by 0.7. And that will give us 25,600. That's called reverse percentages. Question 13. There are only 4 mint biscuits and 1 toffee biscuit in a tin, and there are 5 mint sweets and 3 strawberry sweets in a packet. Michael's mum lets him take 1 biscuit from the tin and 1 sweet from the packet. Michael takes a biscuit at random and a sweet at random. Work out the probability that either the biscuit is mint or the sweet is mint, but not both. So if we do a tree diagram for this, so for the biscuits we'll do mint and toffee. So for the mint it's 4/5, and for the toffee it's 1/5. And then for the sweets, for mint it is 5/8, and for strawberry it is 3/8. And again we'd have the same on here. So mint is 5/8 and strawberry is 3/8. Now we're after only one of them being a mint. So we're after this path here, going down here. So 4/5 times 3/8, which gives us 12/40. Or we're after this path down here and along here, which would be 1/5 times 5/8, which equals 5/40. Now we're not bothered which way around that happens, so we can just add those two together. That one or that one gives us 17/40 for our final answer. Question 14. The diagram shows a trapezium. All the measurements are in centimetres and the area of the trapezium is 46 centimetres squared. Show that x squared plus 2x minus 5 equals 0. Well, to do this, we just need to work out the area of trapezium in algebra. So to work out the area of trapezium, you do a add b divided by 2, multiplied by the distance between them. So 5x add 3x is 8x, 3 add 1 is 4. So we've got 8x add 4 divided by 2, multiplied by the distance between them, so that's 2x plus 3. 8x add 4 divided by 2 is just going to be 4x add 2, and we want to multiply that by the 2x add 3. So we're just going to multiply that out like normal quadratics. So 4x times 2x is 8x squared, so that's that one done. 4x times 3 is 12x, 2 times 2x is 4x, and 2 times 3 is 6. And that has an area of 46 centimetres squared. So to get it equal to 0, we need to take the 46 off both sides. So we get 8x squared, put these two together as well, we've got 16x's there, and then 6 take 46 would be minus 40, and that would be equal to 0. Now you'll see it's nothing like this just yet, but you'll notice that each of these are a multiple of 8. So if we divide through by 8, we get x squared plus 2x minus 5 equals 0, just like it says. It says solve the equation x squared plus 2x minus 5 equals 0. Give your solution correct to 2 decimal places. So we're going to use the quadratic formula for this. So the quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. Where the number in front of the x squared is a, the number in front of the x is b, and the number there is c. So minus b gives us minus 2, plus or minus the square root of 2 squared minus 4 times 1 times minus 5 all over 2 times 1, which is just 2. If we simplify that down, we'd have minus 2 plus or minus 4, and then, so 2 squared is 4, 4 times 1 is 4, times 5 is 20, so this will be taken away, minus 20, which will be like add 20, so this will be the square root of 24. Again, put it all in your calculator if you're not sure, divided by 2. And if you put that in your calculator, to get the plus 1, you get 1.459, and to get the negative 1, you'd have minus 3.45 for your two answers. Question 15, it says the graph of y equals f of x is shown on the grid. The graph G is a translation, so translation means it just moves left or right or up or down, of the graph y equals f of x. Write down, in terms of f, the equation of G. So basically, if we look at this point here, it's just gone 1, 2, 3, 4. It's moved 5 to the right. So if we look at the value of x here, we want to get the same value for y when x is 1 as when x was minus 4. So basically, we just want to take 5 off 1 to get to minus 4. So it's f of x minus 5. The graph of y equals f of x has a maximum point minus 4, 3. Write down the coordinates of the maximum point of y equals f of minus x. Well, f of minus x will mean we'll get the same value for y when x is the negative of itself. So that will be a reflection in the y-axis. So basically, if we reflect that in the y-axis, minus 4 will go to 4 on the x-axis, but the 3 will stay the same because it's still up at 3. So it'll be 4, 3. Question 16. X equals 0.015 recurring. Prove algebraically that x can be written as 1 over 66. Well, if we call that's x, so 0.151515, you must write that out because the examiner needs to know that you know what that means. So the dot being above the 1 and above the 5 means that the 1 and the 5 recur. So if we times that by 10, we'd get 10x is 0.1515. Now, the reason why I've done that is to get rid of this 0 here. I then want these two digits on the other side. So if I times that by 100, I'll end up with 1,000 x's equals 15.1515. And now we've got the same decimal places after the decimal point. So we can just take these away from each other. We get 990x equals 15. So if we do x must be 15 divided by 990. If we divide that by 5, we get 3 5s in 15 and 198 5s in 990. And then both of those are divisible by 3. Where we can check that is 1 add 9 is 10, add 8 is 18. So because that they add up to a multiple of 3, that must be divisible by 3 as well. If you can't do that in your head, just do it on a calculator, and that will cancel down to 1 over 66. Question 17. The table gives information about the weights of 60 parcels. Draw a box plot. Now, for a box plot, we need the lowest, the highest, the lower quartile, the median, but we need the upper quartile. Now, we've been given the interquartile range instead. So to work out the upper quartile, we need to do 2.7, add 1.7, which is 3.4 kilograms. Sorry, 4.3 kilograms, apologies. So if we draw those in, the lowest value is at 1.5, so do this as accurately as you can. So we draw a line at 1.5. The highest value is at 6.3, so we've got a line up there. The lower quartile is at 2.7, which I think is just there. The upper quartile is at 4.3, is just there. And then the median is at 3.2, which is just there. Now, the upper quartile and lower quartile encase the median, and we join those up with the whiskers. Question 18. The graph shows the velocity, v meters per second, of a rocket at t seconds. Find an estimate for the rate of change of the velocity of the rocket at t equals 2. Well, the rate of change of velocity is the gradient of the graph at that moment. So what we need to do is we need to draw a tangent at t equals 2. So at t equals 2, we need to draw a tangent to the graph as accurate as you possibly can. Now I'm just a little bit out there, so make sure you're just touching the graph, okay? Now, to do the gradient of that, we need to look at this distance here, which is at 0 up to 40, if you carry that on. So this distance here would be 40, and along here, that's at 1.3, so this all the way to here would be 3.7. So 40 divided by 3.7 would give us a gradient of 10.8. So it says find an estimate for the rate of change of velocity. So in fact, it doesn't tell you what they're measuring, does it? So that doesn't tell you whether it's meters or not. Oh, sorry, yeah, meters per second. So it'd be meters per second squared. Now, be really careful with that, be as accurate as you can. You might get a slightly different answer to me because your line might be slightly different, and it should definitely be touching here. So just be as accurate as you possibly can. There is a range of answers for that around about 10.8. Question 19. A road is 4,530 metres long, correct to the nearest 10 metres. Kirsty drove along it in 205 seconds to the nearest 5 seconds. The average speed limit for the road is 80 kilometres an hour. Could Kirsty's average speed have been greater than 80 kilometres an hour? Well, we're going to use speed equals distance over time. The maximum value of her distance, so if we want to go see what her maximum speed is, we want to do this as the maximum value for the distance would be half of 10 metres is 5 metres. So we go 5 metres either side. So that'd be 4, 5, 3, 5 is your maximum, and 4, 5, 2, 5 as your minimum value. But we're going to use the maximum value because we want the biggest possible speed. So it'd be 4,535 for the maximum distance possible. And we want to do that distance in the shortest time possible to get the maximum speed. So 205, half of 5 seconds is 2.5. So the lower end would be 202.5 and the upper end would be 207.5. So we're going to use the 202.5 because a bigger number divided by the smaller number gives us a bigger answer. Now that will give us 22.39506. Well, that's metres per second. Now leave that number in your calculator because we need to change that into kilometres an hour. So to convert the metres into kilometres, we need to divide that by 1,000, that answer. And then to convert the seconds into minutes, we need to times by 60. And then minutes into hours, we times by 60 again. So keep this in your calculator, divide by 1,000, times by 60, times by 60. And that will give us 80.6 kilometres an hour. So we need to write our final answer. Yes, it could have been just over 80 kilometres an hour. Question 20. Here are the first 4 terms of a quadratic sequence. Find an expression in terms of n for the nth term of the sequence. Well, to find the nth term of the sequence, we find the second difference. So, the difference between 7 and 18 is 11. The difference between 18 and 3 is 15. And then the difference here is 19. And if we take those away from each other, we see there's a second difference of 4. Because it's a second difference of 4, we half that, so it must be a 2n squared sequence. Now, 2n squared, 1 squared is 1, double it is 2. 2 squared is 4, double it is 8. 3 squared is 9, double it is 18. and 4 squared doubled is 32. So if we take this away from our original sequence, 7 take 2 is 5, 18 take 8 is 10, 33 take 18 is 15, and 52 take away 32 is 20. So our quadratic sequence is 2n squared, our linear part of the sequence is 5, 10, 15, 20, which is just 5n. It's the 5 times tables. So overall, it would be 2n squared plus 5n. Question 21, it says g of x equals 4x over 3 minus x, and f of x equals 2x minus 5. Given that x is greater than 3, find out the exact value of x such that g of minus 1 of x, so the inverse of g of x, equals f of x. So the first thing I need to do is find the inverse of g of x. So if we call this y equals 4x over 3 minus x, I basically want to make x a subject to that formula. So if I take the 3 minus x up here, that'll give us that. If I expand the brackets, I have 3y minus yx equals 4x. And now what the x is on the same side, so I will have 3y equals 4x minus yx. Plus yx. There's a minus on this side, so it comes a plus on the other side. So to get x on its own, we need to factorise that. So we'd have 3y is equal to x brackets 4 plus y. And then divide through to get 3y over 4 plus y for x. Now, the actual g minus 1 of x then, so the inverse of x, g of x, sorry, is we just put the y's back to x's, so we'd have 3x over 4 plus x. Now we want to put that equal to 2x minus 5, so we've got 3x over 4 plus x equals 2x minus 5. So take this the other side, we'll have 3x equals 2x minus 5 times 4 plus x. If we expand that out, we end up with 3x equals 8x, so 2x times 4 is 8x. 2x times x is 2x squared, minus 20, and minus 5x's. Now if we simplify that all together and get everything on the same side, we end up with nothing on this side, we end up with 2x squared, and we've got plus 3x on this side. Take the 3x's off, means we've got no x's, so we'll just be left with a minus 20. So if we divide through by 2, we'd end up with x squared minus 10 equals 0, so x squared equals 10, so x will equal the square root of 10. Now, because it says that x has got to be greater than 3, the square root of 10 can be plus or minus the square root of 10. So x would be plus 3.16 and so on. So the exact value would be plus the square root of 10.